everyone. In this session, we are going to discuss about the time response analysis in time domain specifications. So, in this we will understand how to measure the system performance using time-based parameters. So, let's recall the last class topic. In last class, we discussed about the first and second order system response in time domain specifications. We discussed about the impulse response with their output and step response with their output. And today's topics for discussion is Introduction to Time Domain Specifications, Rise Time and Peak Time Specifications, Settling Time and Overshoot Specifications, Steady State Error Specifications, and Practical Problems. So now let's move on to the empathize part of this design thinking stage, that is why this topic is important. So in real world system, we often observe unstable voltage regulations in power systems and oscillations in motor control systems and slow response in circuit protection. So if the need or this problem is not solved means we can lead a system instability and potential failures, equipment damage due to excessive oscillations, and poor performance in critical applications. So now we move on to the need for the solution of this topic. So the limitations of existing methods includes the isolated analysis of individual specifications, complex calculations for system optimization, trade-off conflicts between the specifications of some different time domain specifications. So let's define the defining stage of DT stage, that is Introduction to Time Domain Specification. So let's define the time domain specification as it is a quantitative measures that describes how a system responds over a particular time period, and they help us to describe the dynamic behavior and evaluate the performance quality and guide system designs. And the key parameters includes, that is a rise time, peak time, settling time, and overshoot. That rise time is represented as TR, peak time as TP, and settling time as TS, and overshoot is represented as the MP. Now see about the rise time and peak time of time specifications. So the rise time, it is the time required for the response to rise from 10% to 90% of its final value. So it indicates how fast the system responds. So TR is equal to pi minus theta divided by omega d. Here theta represents the cos inverse of 1 divided by epsilon, and omega d is equal to omega n into root of 1 minus eta square. So it indicates the response speed of the system. Next we see about the peak time. It is the time taken to reach the first maximum peak of the response. So it represented as Tp, that is equal to pi by omega d. So, and it depends on the damping ratio and it inversely proportional to omega d, and it relates to oscillation frequency. As faster system has a smaller rise time and peak time. Next one is a settling time and time overshoot specifications. So settling time is the time taken for the response to stay within a certain range, usually plus or minus 2% or plus or minus 5% of the final value. So it indicates the system stability. So T of S approximately equal to 4 divided by, so eta omega n for 2% criterion, inversely proportional to damping ratio and critical for precision applications. Next one is the overshoot, and is how much the response exceeds the final value. Higher overshoot means more oscillations. A damping increases, overshoot decreases. So MP is equal to e power epsilon pi by root of 1 minus epsilon square into 100%. And 0 for critically or overdamped systems. So it affects the system stability. And these are all the steady state error specifications. And in the steady state error is the difference between the desired output and the actual output as time approaches infinity. So it measures the accuracy of the system. We use error constant, that is Kp for step input, Kv for ramp input, and Ka for parabolic input. And it measures the accuracy of the particular system. And the practical problems in real systems, we face challenges like trade-offs between conflicting specification, parameter sensitivity to variations, non-linearities in real systems, noise affecting measurements, and it gives the troubleshooting approaches, system identification techniques, parameter tuning methods, and compensation techniques or compensation strategies. And this is the activity for this session. And let's move on to the summary part of this session. In time domain specifications, define system performance. Rise time and peak time indicate speed. Settling time and overshoot indicates the stability. And steady state error indicates the accuracy of the system. So understanding this helps in designing efficient control systems. Thank you.